What if artificial intelligence wasn't controlled by a handful of giant corporations, but instead ran as an open, global, competitive marketplace where anyone can contribute models, compute, or intelligence, and get paid in real time for producing something useful? That is Bittensor. In this video, we're going extremely deep. We'll cover the full technical architecture, every major component, Yuma consensus in detail, dynamic TAO, alpha tokens, emissions, the metagraph, and a thorough breakdown of the most important subnets across the network. By the end, you'll understand exactly how Bittensor works in 2026. Let's begin. What is Bittensor? Bittensor is a decentralized Layer 1 network built on substrate that creates incentive markets for machine intelligence and related digital commodities. It is not training one giant closed model like OpenAI or Anthropic. There is no single Bittensor LLM. Instead, Bittensor is an economy of specialized subnets. Each subnet is an independent marketplace focused on a specific AI or compute task, language model inference, and decentralized training, confidential compute, image generation, financial prediction, storage, coding agents, scientific research, and more. Miners produce the actual intelligence or commodity. Validators score the quality of that work. The network pays everyone in TAO according to how useful their contribution is judged to be. The goal is often described as building the Internet of AI, or a collective neural network that improves through open competition. The foundation is the subtensor blockchain. It produces a block roughly every 12 seconds and records all economic activity. Registrations, stakes, and consensus results. There are 4 primary roles. 1. Miners run models or provide services. They respond to queries or perform the work defined by the subnet's incentive mechanism. 2. Validators continuously evaluate miners by setting weight vectors. They must hold sufficient stake weight to receive a validator permit. 3. Subnet owners/creators register the subnet, define the incentive mechanism, set hyperparameters, and receive a share of emissions. 4. Stakers/delegators stake TAO to validators to earn a share of validator dividends. Each subnet maintains a metagraph, a live on-chain data structure that tracks every registered neuron, their stake, trust, and consensus scores. A subnet typically has a maximum of 256 UID slots. New registrations can prune the lowest performing non-immune neurons. Freshly registered neurons enjoy immunity. This is the most important technical mechanism. Yuma consensus converts subjective scores into objective emission distributions. Here's how it works. Every epoch, each validator submits a weight vector ranking the miners it has evaluated. These weights form a matrix. The algorithm calculates a stake-weighted consensus, typically using a kappa threshold around 51% of stake. Any weight significantly higher than the consensus is clipped down. This prevents individual validators from inflating rewards for their preferred miners. The clipped stake-weighted ranks produce an aggregate ranking for every miner. Miner emissions are distributed proportionally to these ranks. Validators earn bonds with the miners they correctly evaluated. Their dividends come from the strength of those bonds, weighted by the miners' emissions. Over time, bonds use exponential moving averages, so relationships evolve based on consistent performance. There is also a commit-reveal mechanism using time-lock encryption, so validators cannot simply copy each other's weights in real time. This creates a game-theoretic equilibrium. Validators are incentivized to score accurately, and miners are incentivized to produce the highest quality outputs. In February 2025, the network activated Dynamic TAO, the biggest economic upgrade since launch. Before DTAO, root validators voted on emissions. After DTAO, every subnet has its own alpha token. Each subnet runs an AMM pool pairing TAO and its alpha. The price of alpha is determined by the ratio of TAO to alpha in the pool. A subnet's TAO emission is driven by its alpha price. Stakers can stake TAO into a subnet's pool and receive alpha, or stake on the root network. TAO Tokenomics. Hard cap of 21 million TAO. No pre-mine, no VC allocation. All tokens enter via emissions. The first halving occurred in December 2025, reaching 10.5 million, now 0.5 TAO per block. Future halvings will continue. Within each subnet, emissions are split, 18% to the owner, 41% to miners, and 41% to validators and stakers. Recent upgrades further concentrate emissions toward the highest performing subnets, while still allowing the long tail some flow. There are currently around 128 active subnets. It is impossible to cover every single one, so we will categorize and deep dive the significant ones. Major categories: inference and agents, training, compute, finance, vision, storage, and coding agents. Check TAO stats for live rankings. SN1. Apex focuses on advanced LLM inference and agent workflows. Miners run models that use tools, web search, and code execution. SN3. Templar. Decentralized pre-training. Famous for the Covenant 7.2b run, demonstrating frontier-scale training is possible permissionlessly. SN4. Targon. Confidential compute. Uses trusted execution environments so data remains private even from hardware operators. Strong revenue traction. SN64. Chutes. An AI inference marketplace serving models at competitive prices, often ranking as a top provider on OpenRouter. Enormous volumes. SN51 Liam for GPU compute. SN62 Ridges for coding agents. SN8 Proprietary trading for crowdsourced trading signals. SN44 Score for computer vision. SN9 IOTA for large-scale training at home. Others include Synth, Bitcast, and Hippias. Each subnet owner defines a unique incentive mechanism, the way validators score miners, while using the same underlying consensus engine. You can stake TAO to validators, run a miner, run a validator, or register and operate your own subnet. All of this is done via the official Bittensor CLI and Python SDK. Cold keys hold funds. Hot keys perform operational actions. The network is still evolving rapidly. Emission formulas, commit reveal, and subnet capacity continue to be refined. Challenges include sustainability of long-tail subnets, concentration of stake, and the complexity of evaluating true intelligence versus gaming. Yet it remains the most advanced live attempt at a decentralized, incentive-driven market for machine intelligence. If this deep dive helped you, like the video, subscribe, and comment which subnet you want a full breakdown on next. This is Bittensor in 2026. Thanks for watching.